Hey Algebra students, today we're going to talk about arithmetic sequences again, specifically dealing with the explicit rule. Okay, so if you guys recall, arithmetic sequences kind of have a linear fashion to them. For example, we could start with some initial value for our first term and then increase every single term thereafter by a common difference. Very similar to increasing by the same rate of change or a constant rate of change, like a linear equation. All right, and so just like with linear equations, we can write the equation as y equals mx plus b, where b is kind of our y-intercept or zeroth term in our function, and this being our slope. We can kind of do the same thing with our explicit rule. Okay, where our explicit rule can be written in terms of a common difference times n, which is our variable, that's our input variable, right? an is our output variable, n is our input variable, and this being our common difference similar to our rate of change. So just like we have y equals mx plus b, we can do the same thing with an explicit rule, where it's our rate of change times our input variable plus the 0, something term, okay? And so our explicit rule can actually be written as an equals common difference times n plus whatever the 0th term in our sequence is. Now typically though, we don't start with the 0th term, okay? So 5 is not the 0th term. If you guys recall, 5 is a1, okay? 7 is a2. 9 is A3, 11 is A4, first term, second term, third term, fourth term. If we wanted to find the 0th term, technically we don't even graph the 0th. The 0th term isn't even a part of our sequence. But if we go back one step, right? If we were to go subtract 2 more, because in this case our common difference is 2, we could actually find our secret imaginary 0th term, even though that's not a part of the sequence, okay? So 3 is not a part of our sequence, 5 is the first term of it, but if I wanted to find the 0th term, all I'd have to do is subtract my common difference, go back one, okay? And we could write the rule for that arithmetic sequence as 2 times n, because 2 is our common difference, plus 3 for our 0th term. And this very much models the y equals mx plus b scenario, where we have our y-intercept, which is when x is 0, or our input would have been 0. Remember, sequences just start with an input of 1, but we could identify and see what would have happened if we looked at the 0th term, if there was such a term, okay? And so we've got our rate of change, how much it goes up by, plus our, for all intents and purposes, 0th term. And if we tried this with n equals 1, we could find a1 equals 2 times 1 plus 3. 2 plus 3 is 5. And guess what? That works out, okay? And if I wanted to find what a4 was, I would plug in 4 for n. 2 times 4 is 8, plus 3 is 11. Fourth term is 11. And so our explicit rule is really useful because if we want to find, let's say, our 20th term in a sequence, we do not have to count to 20 to find it. We can find our 20th term just by plugging in 20 for n. 2 times 20 is 40 plus 3. Our 20th term is 43. And so our explicit rule gives us a direct equation to find any term we ever want really quickly. So this is how we find our explicit rule. But there's a second way you could also find it. Okay, because this is the less common method, right? That's kind of a trick. You can write that down, put that in your notes if you'd like to. That's kind of a shortcut and a trick. Usually, the way that the explicit rule is written is d times n minus 1 plus a1. Usually, they don't refer to the 0th term since the 0th term doesn't actually even exist in our sequence. Because our sequence starts with our first term, most people say that this is the explicit rule. But then you have to solve it out anyways. So watch. This is what I mean. an equals our common difference times n minus 1 plus our first term, which is 5. Well, watch what happens. When I distribute it, because you have to simplify this. When I distribute this, we get 2n. We distribute that. We're subtracting 2 from 5. 2 is our common difference. We're subtracting our common difference away from this first term anyways. Well, if I subtract our common difference away from our first term, we get to the 0th term, right? If I start at my first term and go the common difference in the other direction, subtract it away, I get to my 0th term. That's why I use this shortcut if you'd like, but you're always welcome to use this method, okay? And I'm not done over here, right? So we have an equals 2n minus 2n plus 5 is plus 3. And guess what? That's what we had here when we just substituted directly in 2n, right? We went to plus 3. So either way you want to use is fine with me. Method 1, to find the explicit rule, use an equals dn plus the 0th term that does not exist. You have to then find it just by subtracting our common difference. Or an equals 2n minus 2 plus 5 is 3, using this formula, d times n minus 1 plus a1. So this is actually known as the more common way that we write an explicit rule, but you have to simplify it at the end. And notice it looks like it's a y equals mx plus b format, where n is our input and an is our output. Okay, so let's practice a couple of these. an equals 3, 8, 13, 18, etc. Now, if we're going to use the an equals d times n minus 1 plus a1 formula. So I'm going to do it this way first. I'm going to show you, you get the same answer either way. I'm going to do a couple problems like this, and then you can start choosing which way you want to use. Okay, I don't care. I'm not the one that's doing your work for you. I'm just showing you both ways to solve this, to find the explicit rule. So this is if we're finding the explicit rule. Last Tuesday you found the recursive rule. This is the explicit one. Okay, so first I have to find what our common difference is. And it looks like every time I'm adding 5. So d equals 5. So an equals 5 times n minus 1, that's always there, plus, hey, that is my first term, 3. Okay? Ooh, almost tripped on the chords again. I have to distribute this out, and I end up with 5n minus 5 plus 3. Okay? So we get an equals 5n minus 5 and plus 3 is minus 2. Okay? 5n minus 2. Remember that. Write that down. 5n minus 2. That is if we use this formula, which works every single time. This formula will always work in finding the explicit rule. an equals d times n minus 1 plus a1. Plug in our d, plug in our a1, distribute, and simplify by combining like terms. 5n minus 2. Okay? That is the first way you could have solved this. Alright? I'm going to show you the second way you could have solved this. Remember, the other formula I gave you, right up here, an equals d times n plus a0, so the 0th term, the imaginary 0th term that doesn't actually exist. Well, if I'm going in this direction, you're adding 5. If we go in this direction, we would subtract 5. This is our a1, this is our a2, our a0, our 0th term. Subtract 5 from 3 is -2. So we would just take that and plug that in right there. We still have a common difference of 5. So an is the common difference of 5 times n minus 2. Because that's our a0. And guess what? We get the same answer either way, no matter which way we solve this. Okay? So I'll try another one. an equals, let's go with, I don't know, -3, 1, 5, 9. Okay? And let's use this method to find the explicit rule. Right? So we have to identify that we're going up 4 each time. And we have to identify that our first term is -3. Okay. We have to distribute 4n minus 4 minus 3. So we end up with the equation, the explicit rule 4n minus 7. And we can test that out if you want to. We know what the fourth term is. 4 times 4, I plugged in 4 for n, and then subtract 7, because 4n minus 7, 4n minus 7. The fourth term is 16 minus 7, which is 9. We already know that, so check, it works out. See? Okay. And in fact, if I wanted to find the 11th term, we plug in 11 right there for n. 44 minus 7 is 37. Okay? So it works out. Oh, and if I would have wanted to do the other method, and remember, I like the other method better, I just have to remember if I'm going in this direction, I have to subtract 4, right? And so a0 is -3 and -4 makes -7. Our formula, dn plus a0. Common difference is 4. A0 is -7. Look at that, same answer. Okay, so however you want to write the explicit rule is fine with me. Okay, but eventually you're going to get to the point, hopefully, if you use my trick, okay? If you use my trick where we go an equals dn plus a0, it should start being really, really quick, okay? Right? You should start seeing common difference is +6, okay? Right? Go up 6, up 6. If I go in the other direction, I'm subtracting 6. A0 is 7. Boom. Nice and simple, very quick way to find the explicit rule. We can always check our work. Plug in 1 for n. 6 times 1 is 6, plus 7 is the 13 we thought it would be for the first term. Plug in 2 for n. 6 times 2 is 12, plus 7 is 19. That works. Plug in 3 for n. 18 plus 7 is 25. So it is working for each of these terms, a1, a2, and a3. But this is our explicit rule answer. Okay? I hope this video has helped. Today has just been writing the explicit rule for an arithmetic sequence.